Hello students, we are in the second part of similar triangles and the chapter similarity, and we are into basic proportionality theorem and converse of basic proportionality theorem. So theorems are very important to learn because in geometry you apply those theorems to solve given problems. So two things are there. First, the proof of the theorem should be known, and secondly, the application part which has to be used has to be known. In our previous chapter we studied about previous video we studied basic proportionality theorem, which stated, this is BPT, here is a triangle ABC, which stated if a line is drawn parallel to any one side of a triangle, then it divides the remaining two sides proportionally. That means DE is drawn parallel to BC, and that means given is DE parallel to BC. In BPT, DE is parallel to BC is given, and we have proved in that AD by DB will be equal to AE by EC, that is by BPT. Therefore, in BPT this now has to be applied in all those problems where in a triangle the line is drawn parallel to one side is given. So, the remaining two sides will be proportionally divided by the given line, that is BPT. In my previous video you can have a look. Now, in the next video is this one. Here we are going to study the converse of BPT. It is very simple. In BPT the line was given parallel and we proved that the sides were proportional. In this it is given the sides are proportional, AD by DB is equal to AE by EC. So, the sides are proportional, then the line is parallel, that means DE will be parallel to BC. The line which divides two sides proportionally is parallel to the third side of the triangle. So, I will read it out. Converse of BPT says, if a line divides any two sides of a triangle proportionally, that means DE divides the two sides AB and AC proportionally, then the line, that means this line is parallel to the third side, that means DE is parallel to BC. That we can now prove, or we are going to prove that. So, assume that through D is not parallel to BC. We will prove this by contradictory method. We will assume that D is not parallel to BC. Alright. So, I am starting the proof. Let us assume D is not parallel to BC. So, I am assuming what is given is wrong, and I am telling that suppose let us assume D is not parallel to BC. I am taking this as not parallel to BC. Then outside a line D is the point, outside line BC D is the point. So, outside a line through any point a line can be drawn parallel to the given line. So, D is a point outside BC, D is here, BC is here. So, through this I can get at least one line parallel to BC. So, and only one line parallel to BC, only one line parallel to BC can be drawn from D. So, from D. So, if D is not parallel, then there has to be one line which is parallel to BC through D. So, I will make a construction. I will make a construction assuming that okay, if D is not parallel, then there has to be one line which is parallel. Let D dash be that line. So, in construction also I will add up over here. Let us assume D dash is parallel to BC, which we have drawn. So, we have assumed that. Now, what will happen? Now, if D dash through our assumption is parallel to BC, then we come to application of BPT. BPT we can apply here. Since D dash is parallel to BC, so this implies that AD by DB is equal to AE dash by E dash C by BPT, and this we will take equation 1, we will keep it in our pocket. But also given AD by DB is equal to AE by EC. This we take it as 2. Now we know that things which are equal to the same thing will be equal to one another. That means what will happen? AE dash by E dash C is equal to AE by EC. If I add 1, then AE dash by E dash C plus 1 is equal to AE by EC plus 1. Now, by applying mathematics, simple mathematics, we get, and taking LCM, we get is equal to AE plus EC by EC. Now, AE dash plus even AE dash plus E dash C is equal to AC. And AE plus EC is also equal to AC. So, AC is cancelled. So, E dash C is equal to EC. Now, C is a common point in which it is being told that C and C dash are equal. How this is possible? This is only possible that when E dash will coincide with E. Have a look. We are coming to a conclusion that C dash and C are equal. So, this is only possible. This is only possible when E dash coincides with E, or E dash that is E dash and coincides with E, that is E dash and E are same points. So, if I have taken D is parallel to EC, D dash is parallel to EC, that means E dash is the same as E. So, D is parallel to EC. This finally proves that D is parallel to BC. D is parallel to BC. Did you understand? So, this is what is converse of DPT. So, what is the takeaway? That if in this figure, if you see, if we can get PE by EQ is equal to PF by FR, that means EF will be parallel to QR. Did you understand? So, we will do some application problem. As soon as we learn a theorem, we should always do application problems. So, I will wait for you to copy this. So, you copy this by pausing the video. You should see this video on a bigger screen, either on a desktop, or you can always mirror your Android phone with your smart TV. These things students you can do now. You should be techno savvy. At home all the TVs now can be mirrored through your Android phone. Now we go to the next part, is that application of what I have written, what we have learned, application of what we have learned. So, let us see. Here the first question, the question says that EF is drawn like this, and first question says P is 3.9, EQ is 3, PF is 3.6, FR is 2.4. Is EF parallel to QR? That is only possible if P by EQ is equal to PF by FR. So, you will find question number 1, P by EQ is equal to 3.9 by 3, that is equal to 39 by 30, that is 13 by 10. Now we get PF by FR, that is equal to 3.6 by 2.4. This is 36 by 24. I take the decimal off. Now 12 3 is a 36 and 12 2 is a 24. So, P by EQ is not equal to PF by FR, this implies that EF is not parallel to QR. EF is not parallel to QR because lines are not divided proportionally. So, that means the converse of BPT is not applicable over here. Now, next again we will go to the next sum. So, I keep this blank because I am going to use it. So, I remove the 3.9 over here, 3 over here, 3.6 over here and 2.4 over here. Now, we go here. Now, what are the lengths given? P is equal to 4, QE is equal to 4.5, PF is equal to 8 and RF is equal to 9 centimeters. All of them are in centimeters. So, P by EQ is equal to 4 divided by 4.5. So, 40 by 45, 5 8s are 5 9s are. So, we are getting the ratio 8 by 9 and PF by FR is 8 by 9. That means P by EQ is equal to PF by FR. This implies that EF is parallel to QR by converse of BPT. Done. Now, next question, third one. I will remove this part, then I will remove this whole thing. Now, let us see next question. This has to be removed, this has to be removed, this and this. Now, next question we see PQ is 1.8, PQ is 1.28, sorry, PQ is 1.28 and PR is 2.56, PR is 2.56, P is 0.18 and PF is 0.36. So, EQ first we will get, EQ will be equal to 1.28 minus 0.8, 1.28 minus 0.18, that is equal to 1.10 centimeters. Alright, then we will get FR, FR is equal to 2.56 minus 0.36, that is equal to 0.2 and to 2.20 centimeters. So, now we get the value, that means this is 1.10 and this is 2.20. Now, we get PE is equal to 0.18 divided by EQ 1.10. So, it is 18 by 110, that is equal to 9 by 11 and then PF by FR is, now PF is equal to how much? 0.36 and FR is equal to how much? 2.20, that is equal to 36 by 220. So, this will go 4 9s are, 4 5s are, 4 5s are. Let us see, this is 9 by 55 and here the calculation again, let me see, this is 2 9s are and 2 5s are and 2 5s are. So, 9 by 55 and 9 by 55. So, this becomes how much? This becomes P by EQ is equal to PF by FR. So, by converse of BPT, we get, by converse of BPT we get EF is parallel to QR. Let us once again do this sum. So, we now move on to the third sum. The third sum says, let us have a look, PQ is equal to 1.28 and PR is equal to 2.56, P is equal to 0.18 and PF is equal to 0.36. So, I have to get EQ. So, EQ will be equal to 1.28 minus 0.18, that is equal to 1.10, and Fr will be equal to 2.56 minus 0.36. 2.56 minus 0.36, that is equal to 2.20. Now we get PE by EQ. PE by EQ is 0.18 by 1.10, that is 18 by 110, that is equal to 2 nines are 2 fives and 2 fives are. Now here it will be 0.36, 2.20, that is 36 by 220, that is equal to 4 nines are 4 fives and 4 fives are. We are getting P by EQ is equal to 9 by 55, which is equal to PF by FR. This implies that, so line is divided proportionally, that means EF is parallel to QR. So children, we have finished converse of BPT and a few application. In the next chapter we will see angle bisector theorem and then combination problems of BPT and converse of BPT. Thank you.